You've been practicing how to factor quadratic trinomials when the coefficient of x squared is 1. I'm doing all these quadratics with x squared, but you can have quadratics in terms of anything. At higher levels of math, you'll often see something like this: sine squared x plus 3 sine x plus 2, and you have to factor that as sine x plus 1 and sine x plus 2. So this is a huge skill. As you can see, this is a quadratic in terms of sine squared. I'm going to mostly use x squared. I'm making this video quickly as I leave for the weekend. What we're going to talk about is the coefficient of this x squared, or the squared term, being different than 1. And I do it a certain way, and I'm going to try to show you a different way than I normally do it as well, so you can kind of practice both and see which works best for you. First way that I attempt to look at this is, let's say something like 2x squared plus 5x plus 3. I want you to list the factors of 3, and I want you to list the factors of 2, and I want you to combine the factors of 2 and the factors of 3 in every possible combination. So that's 1 and 6, and that's 2 and 3. 1 you get by taking 1 times 1. 2 you get by taking 2 times 1, and 1 times 3 to get 3. And then 6, right? And now with these numbers here, you are going to look to add factors if both this term and this term are positive. So now it's A and C have to be positive. Add those looking for the middle number. So in this case, 2 and 3. So how do we get a 2 and a 3? Well, we get a 2 and a 3 by taking an x and a 2x. That's the only way to get a 2x squared using integers. We're not going to put a square root of 2 and a square root of 2. We're only going to use integers when we factor. And now, how am I going to produce this 2? I'm taking this right here, and I'm multiplying it by the 1. So what that means is, what has to go here is the 1, forcing the 3 to go here. What goes in these last spots is either a 1 and a 3 or a 3 and a 1. To get the 2 and 1 to multiply together, the 1 has to be in the other parenthesis here. Now the signs, since they're both positive, it's either plus plus or minus minus. You get the sign from here, so it's plus plus. I know that's not easy. I know you might be thinking like, whoa, he went way too fast. So we'll do a lot more examples. Another way, the other way of doing this problem is taking 2 times 3, and that's 6, and look here, and think of the factors of a times c. So remember, ax squared plus bx plus c. Take a times c, which in this case is 6, and list the factors of 6. If a and c are positive, find the factors of 6 that add to 5x, and rewrite the quadratic. Instead of 2x squared plus 5x plus 3, take the two numbers that add, in this case to get 5, and write it 2x squared plus 2x plus 3x plus 3. Now what you're going to do is you're going to group these two terms together, and you're going to group these two terms together. And in those two groupings, you are going to look for a common factor. In this case, it's a 2x, and I get an x plus 1. If this quadratic trinomial factors and you did it correctly, what should be left when you take the common factor out of this group is an x plus 1. Notice they have a common factor of 3, and you take out the x plus 1. Now, here's where it gets tricky. Both terms have an x plus 1, which I can pull out, and I'm left with a 2x plus 3. You get the exact same thing as I got over here, whichever method works best for you. Let's try another example or three. So 3x squared minus 2x minus 5. So I like writing the factors of A and the factors of C, combining these in every possible way to look for, in this case, because this is positive and this is negative, a difference of 2. 3 and 5 have a difference of 2. You get a 3x squared by taking 3x times x. You get a 5 by taking 1 times 5 or 5 times 1. To get a 3 and a 5, the 3 has to multiply a 1. That forces the 5 here. You get 5x and you get 3x. Now, looking at this, how do you figure out the signs? Because one of them is negative, it's plus minus or minus plus. The bigger product gets the sign. What's bigger, 3 or 5x? Sorry, 3x or 5x? 5x is the bigger product, so it gets the minus and that gets the plus. The other way of doing this is saying 3 times 5 is 15. What are the factors of 15 that combine to have a difference, since one of them is negative is 2? That's 3 and 5. I'm now going to write this 3x squared 5x 3x minus 5. These two middle terms have to combine to get a negative 2. So it would be a minus 5x and a positive 2. Now, group the first two together, take out the common factor of x, and you're left with 3x minus 5. Group the other two together, there is no common factor, so group it as 3x minus 5. What's the number sitting right there? That's a 1. Take out the 3x minus 5, and you're left with x plus 1, which is the same answer I got over here. If you had written this the other way and said, okay, well, it's 3x squared, I'm going to split the middle term and write it as plus 3x minus 5x minus 5. Well, now if you group these terms together, you take out a common factor of 3x and you're left with x plus 1. If you take out just a 5, you're left with negative x minus 1. So you can't take out a 5, you have to take out a minus 5, in which case you'd be left with x plus 1. Now you have the x plus 1 common factor, and you're left with 3x minus 5. Either way, you get the same answer. You might do a combination of the two. You might multiply the 3 and the 5 together to just get these numbers, which is every possible combination of the factors of 3 and the factors of 5. If you look at our first two examples, I've made it easy because the numbers have been prime numbers. I had a 2, a 3, and a 5 as my numbers. It gets harder when there's more and more factors of those of A and C. Let's take a look at an example. Okay, another example. 6x squared plus 7x minus 49. Alright, it's time to put in that hidden little Easter egg to make sure you're watching the video. What I want you to do is, I want you to bring your planner to class. And if you don't have a planner, I want you to have your laptop on your table upside down. And then I'm going to ask you a random question. I'm just going to say something like, hey, Chai, what's your favorite holiday? And Chai, and anybody else who's watching this video, your response has to be, Tom Hanks and Meryl Streep were great in The Post. No matter what question I ask you, that's your answer. Okay, so have your planner out, have your computer flipped upside down. If you don't have your planner, I'm going to ask you a question, and you're going to say, Tom Hanks and Meryl Streep were great in The Post. So, the first couple of students I might ask about the movie, so it doesn't look like you have some kind of inside, track. All right, back to this. you can multiply 6 and 49, and 6 times 49, what is that? 54 plus, that's 294? Is that right? Yikes, right? I think that's good. Yeah, 294. I don't know the factors of 294. That's why I like my method of writing 1 and 6, 2 and 3, the factors of 6, and then writing the factors of 49, 1 and 49, 7 and 7. And then looking here, and I know I don't need to combine 6 times 49 because that's going to be 294, and 294 and 1 aren't going to have a difference of 7. So I'm already starting to look down here and I go, oh look, if I take a 3 times a 7, I'm going to get 21. And if I take a 2 times a 7, I'm going to get, and I shouldn't circle both because then it'd be confusing, although they're the same number, I'm going to get 14. And if I get the difference of 21 and 14, I'm going to get 7. Now, once you have those numbers, you may want to flip to the other method and say, okay, this is 6x squared plus 21x minus 14x minus 49. Look for the greatest common factor in the first two terms. That's a 3x, and you're left with 2x plus 7. You know you have to be left with a 2x plus 7. The only way to get a plus 7 from negative 49 is to factor out a minus 7. That would also make this 2x negative 14x. Now take out that common factor, get 2x plus 7 times 3x minus 7. I would have come over here and said, okay, I know I need to get a 6x. That's a 2x and a 3x. That's the only way to get a 6x squared, or 1x and 6x, but I've already ruled those out as possibilities. Now the 3 has to multiply a 7, and the 2 has to multiply a 7. Because these two numbers are both 7, it doesn't really matter which one goes where. Bigger product gets this sign. What's bigger, 21 or 14? 21 is bigger, so that's the plus, and there's your minus. The sign of B goes to the bigger product. I know I have a positive and negative because A times C is negative. Good? All right. Last example, if we said 6x squared plus 11x minus 10. Factors of 60, 1 and 60, 2 and 30, 3 and 20, 4 and 15. There it is, by the way, but we'll keep going. 6 and 10, and 7, no, 8, no, 9, no, 10. Yes, we've already got it. I like to go in an order so I can make sure I get it. 4 and 15 have a difference of 11. So how could I get a 4 and 15? Right? And when I do it this way, I need to split the middle term. If I had written it this way, I would see the way to get a 4 and a 15 is to take 3 times 5, there's your 15, and 2 times 2. The first two numbers over here give you the 2x and the 3x. The 3 has to multiply a 5, the 2 has to multiply a 2. What's the bigger product, 4 or 15? 15's bigger, plus goes there, minus goes there. 10 likes to do this, and I learned it this way too, and I like this method. That's where you split the middle term. Look for common factors. A 3x, so I get a 2x plus 5. Take out the negative 2, and I get a 2x plus 5. If you don't factor out something that makes this look exactly like that, you did it wrong. And there we go. Now I keep giving you examples of things that factor because I want you to practice factoring. If this had not been an 11, but it had been some number that is not 59, 28, 18, 11, or 4, any other number, positive or negative of those that I just listed, isn't going to factor. So if this was a 17, you would have to write does not factor. It is possible that quadratic trinomials don't factor. And there's an algebraic way to force an algebraic trinomial to factor. And we're going to learn that later. But now it's just practicing the factoring skill. making sure we can do this over and over and over again. I know it seems ridiculous, but if you're a basketball player, this is dribbling. You've got to know how to dribble before you can take a shot, before you can even pass the ball, before you can make a layup. You have to dribble the basketball. This will be a skill that just has to be automatic. So right now, it's not fun. It doesn't look like you see the point of it, but it's practice this skill. Practice this skill. All right, thanks for watching. Don't forget to have a great weekend and bring your planner. Peace.